if you have lots of apples, let's say this is like half a gun. You can't even buy a full gun with this, right? But you can buy like 100 apples, right? You live in a world where people are going to steal your apples and eat them for themselves, right? And at this point, you almost wouldn't care if someone stole your apples, right? Because let's say you only had 50 apples that day, like, who cares, right? But if someone said, hey, I'm going to give you 1 gun and 30 apples, right? You'd probably say, okay, like, I definitely don't need more than 30 apples a day. I can sell the remaining 20, and I will have this gun, right? So that no one can steal my remaining 30 apples. So not only will I be more secure, I'll still have plenty of apples to eat, right? And when you get here, someone says, I'll give you 2 guns. You say, well, 2's bigger than 1, you know, and so that's good. But you're not willing to give up nearly as many apples, right? Because you do need apples, right? Remember, diminishing marginal benefit or diminishing marginal returns means that more apples mean that you value your apples less, right? And also, more guns, right? 2 guns is good, but you only have 2 hands. So at the point you get up to like 4 guns, right? You know, you're willing to give up like, you know, 2 apples for like that extra gun. Because a situation where you need more than 3 guns seems fairly improbable. Maybe you can come up with one. Tell me about it. Rambo, yeah, you sit there and shells pile. So we can say, right, that between, we'll just say apples are X, guns are Y, right? Between any good X and any good Y, a consumer is generally going to have a marginal rate of substitution that favors getting rid of the thing that they have a lot of and acquiring the thing that they don't have very much of. You might have someone with a function like that, where it's just flat. They only want apples. Once they have 1 gun, they only want all apples. But again, we're not going to sort of look at that because it's a special case. So, God, we got a second board over here.
Third board.
So let's define a utility function. We can just use a log because it's really simple. So this looks like math, and of course math is scary, so I know. I saw that. I mean, it's true. You have log of x plus log of y equals the person's total utility. Now, the odd thing about this is you're going to get a number out of this. And I'll get back to why utility and the number of utils that a person has doesn't really mean much at all. But this higher number here is better. So if you offer a person, and this is an assumption we're making, you can have something called a bliss point, which again I'll get back to, where you only want a certain number of things, and past that number of things you don't want any more, right? But we're going to assume our consumer can sell his stuff or something, right? He can always do something with it if you give him more stuff. So we're going to assume if you put 1 and 1 here, right? It's always better. This is always worse than if you put, if you put like 2 and 2 here. So the consumer in our economic model is always going to want to buy more stuff. If it's free, he'll always take it. If it costs a little bit, he'll say, well, he'll buy and buy and buy until he only gets like the most minuscule amount of pleasure from that. Okay, so here's the trick about this number. When you chart a utility curve, that's a utility curve, right, between x and y, you could just do this, right? And let's call this utility curve number 1, right? Which means it equals 1. Okay. Right? And then we'll put another utility curve here. And this equals 2, right? And you can keep saying this. What this means is that he is indifferent between each of these. These are often called indifference curves as opposed to utility curves. So if you give him 100 apples, right, and 1 gun, he will be just as happy with that as if you gave him 2 guns and 20 apples, right? Up here, this is going to be 100 apples and 2 guns, right? And here, this will be like, say, 3 guns, right? So you can create all these little kind of point. You can look at all these little points, and it's a continuous function. Let's say guns can be chopped up into pieces, and they still give you a certain amount of protection. Even if you just have like the little muzzle bloater thing, right? It's still protect. You can still smack someone. So he's always going to be happier, right, when he is going out this way, right? So this will give him 1 util. This will give him 2 utils, 3 utils, 4, 5, right? The trick is, oopsies. Let's fix that. There. So the trick with that is, it doesn't matter what you number those curves. I numbered them 1, 2, 3, 4, 5. But the person who has a curve that goes 100, 200, 300 is not going to be any happier than someone with a curve that goes 1, 2, 3. Because you can't compare people. There's no way I could say, I am happier than Dan. Like, I derive more pleasure from anything. And there's no way he could say he's happier than me. You can't sort of in an economic model look at that and say, oh, we're going to count this person's utility more because they seem to be a happier person. You have to count all people, not even equally, but as separate individuals. Again, it's the whole individual versus the group. You can't say because this person sort of acts like another person, you can tell how happy they are. You just have to say, they act like that person, and that person acts a certain way, they act a certain way. Therefore, they might have similar utility functions. But you have to recognize that 100u equals 100 ln x. Is the same as ln x ln y, because they have the same shape of utility function. So all that means is someone with 100 ln x, 100 ln y is going to prefer the same bundles of stuff. So this guy will also, if you label this 100, prefer whatever I had, 1 and 100 was it? The same as he prefers 2 and 20. Even though his utility is supposedly higher. And that's how economists get around the whole concept of how happy is a person. They just say, we don't know how happy, but we know that for whatever index of utility function, the person prefers that bundle of goods. So this bundle will always be preferred to that bundle. All right. So in this world, we just have people spending sort of indiscriminately. People are happy here because there's no way to tell. If you say, how do you maximize this person's utility, it's not like the person has any money, right? So they are obviously going to choose the utility function at infinity, which makes no sense, right? They're just going to buy more and more stuff, and everyone's going to want to have all the stuff in the world, which is consistent with our assumption that everyone always wants more stuff. So the second part of an individual that we have to look at is called the budget constraint. And so usually this takes, if you have x, y, right? Usually this takes the form of the price of x, right, plus the price of y times y is equal to the individual's money. So this person has a certain number of dollars, right? And the dollars that x costs plus the dollars that y costs is equal to the number of dollars that the individual has. So the person is going to say, hold on, lost my train of thought. Yes, the person is going to spend all of their money because, again, they want an infinite number of things. But since they can't have an infinite number of things with a limited amount of money,